So welcome to part 2, the river landscapes section of our feedback. So got here then study figure 13, a diagram showing the features of a lowland river valley, and then choose the correct labels. So if we have a little look here, we'll just do it on here rather than looking at the questions. So this one here, A, is an oxbow lake. Okay, so A is an oxbow lake. We can see there it's separated from the main river channel. So at some point a deposition's taken place and split it off. So we've got this lake here, which will probably dry up and disappear soon. B is not actually in the river. It's not the river, is it? It's next to the river, the side of the river, on this flat area of land between the valley sides. The valley's just the valley edges are there and there, very wide, and that is the floodplain. So all of this area here and on this side over here, that's all the floodplain, flat area of land next to the river. C then is a meander. It's a bend in the river, okay, and we can sort of see they've tried to on the sketch there show a river cliff and a river beach, but it's clearly a meander, a bend in the river in the lower course on flat land. So that's going to be a meander. And then the last one at the end here is where the river's opening up, and obviously it's getting towards the end, so that's going to be your estuary. Okay, obviously, you know, you could put the mouth or something, but it was multiple choice, so the only one that would fit there would be estuary, where it's going into the sea, but also in high tide, where the sea would also be coming backwards up and into this area as well. That makes it an estuary, slightly salted, okay, because it has seawater mixing. So they're the answers down here. So they were all those questions, A, B, C, and D for the estuary. Okay, and on to the next set of questions. Okay, so this one then, sediment is moved downstream in a number of ways. Okay, complete the following 3 sentences choosing the correct one. So we're looking for the correct way that sediment moves downstream. So small sediments are carried in suspension. That's correct on this. So suspension. So they're suspended. If they're small enough, the water and the movement of the water in the river is going to be able to hold the sediments in the water without dropping them off, and it'll be, you know, just hanging around in the water. Okay, so that's suspension, the first one, the smallest part, small particles carried that way. Next then is larger pebbles that move along in hops. So when they're hopping along the bottom of the river, okay, that is called saltation. Okay, saltation means hopping along the bottom of the river. All right, and that's that one. So, you know, they're not in suspension, they do touch the bottom, doesn't quite have enough energy, and then it builds up enough to pick it up again and drops it. Okay, the next one then, the largest material then, is pushed along the riverbed or rolled along the riverbed by traction. Okay, traction is the very large particles being, you know, they don't lift up, they don't get carried unless there's an incredible amount of water in the river. They just roll gradually and slowly and slip and get pushed downstream by the river and the force of the river, but it's a much slower process of traction. Okay, right, next one. Okay, yeah, interesting question, this one. Mixture of sort of, I think most of us got the idea of what we needed to do, but we didn't necessarily do all of the questions. So 6 marker, there's a lot to do here. Okay, there's probably 3 key things that you need to do to answer this question, I would say. So the first one, figure 14. You've got to talk about figure 14. Don't forget that. 1 or 2 of you not mentioning it. You must mention it. Okay, it's got to be really obvious to the examiner that you're talking about the picture and you're looking at the photograph and you're taking evidence from the photograph. Okay, so in figure 14. So in figure 14, we've got an urban area. So there is lots of concrete. Okay. Lots of concrete means lots of impermeable surfaces, therefore water is going to find it difficult to soak into the ground. Okay, so that is going to increase the risk of the river flooding. Something else that you might comment on is the fact that if you look at where this urban area, this city is built, it's very flat land. Flat land tends to be floodplain, and a lot of our cities are built in areas that are floodplain. So you could comment on the fact that because people tend to build on flat flooding areas, This increases the risk of river flooding because you've got more buildings close to a river or in an area of a river that's supposed to flood. Okay, not every year, not all the time, but some of the time. So that would be something else you could mention there. So that would be again, we're talking there about some human factors from figure 14. Physical factors then. Okay. In fact, another human factor people commented on is cutting down trees. Now let's just get this really clear. If we cut down trees, it reduces interception. So water, when it falls, will get caught in the trees, and it then takes longer for that water to get to the river. So there's less chance of it suddenly filling up with water. Okay, and that's the thing about having trees, is they slow the movement of water getting to the river, so therefore it gives the river more time to get rid of that water. There was a few answers that didn't quite seem to get to grips with why trees were so important. That's the key thing, that interception and slowing down the water flow getting to the river. So the water stuck on the leaves. Okay. Next then we could talk about, suggest some physical factors as well. So a good one to comment on was heavy rainfall. If there's been a lot of heavy rainfall, the ground will be saturated, the river will be filled, therefore there is a much greater risk of river flooding. Okay, it's kind of obvious, that one, but it's key, isn't it? If you don't have heavy rainfall, you're not likely to get a river flood, and heavy rainfall is a physical factor. There was some people talking in answers here about slopes, which is fine. We could do that in areas where there are very steep slopes. That can increase the risk of river flooding as the water reaches the river very fast. Okay, therefore filling it up so that it overflows. That was fine. So a number of things like that you could talk about. So the three key things to refer to here are figure 14. Have you commented and linked figure 14 in with what you're talking about? Have you talked about physical factors, so natural things that create more likelihood to increase flooding? And have you talked about human things that are likely to increase flooding? They're the three things, and you've got to make sure you've explored them a little bit, because it does ask you to explain how they increase the risk. Okay, so you need to go into a little bit of detail saying, having concrete increases the risk because water flows into the river much quicker, therefore the river will fill up and flood the land either side of it. Okay, that's what we're looking for in your answers. Okay, again, that idea of extending your sentences, it's really important that you get used to doing that. Not short sentences, detailed full sentences explaining the answer. Okay, that's a good answer here. Look, 6 out of 6, well done. Next then is we move on to this question here, where it's asks us to look at a flood management scheme here, a diagram of a flood management scheme, and it then says suggest how the flood management scheme shown in figure 15 helps reduce the risk of flooding. So we're looking for identification of a few different features, okay, about why they've done things. Now, those I don't know anyone actually wrote it, but someone wrote that it was very similar to, but this is actually Boscastle. So it is actually your case study that was included in the exam. This exam's from a couple of years ago now. And they put it in, look, it's the River Valency. That's the same river, isn't it? Okay, so this is actually part of what they did at Boscastle. Okay, so you can use this as a revision tool as well. So let's sort of start at the top of the river here. What have they done the higher up? So they've put a bend back in the river. Okay, that's the first thing. That they've extended the length of the channel, so therefore it can hold more water. Okay, and it will also slow the movement of water down. Okay, so water will flow slightly slower if it's got to go in a bend as well. So just reducing the pace that the water flows is the first thing. So the question says, how will that reduce the risk of flooding? If the water flow is slower, it gives more chance for the river to river discharge to get rid of all the water before it overflows. Okay. As it says here, form a wide channel upstream. I think most people talked about this. that having a very wide channel here allows more water to be held within the river, so therefore less likelihood to flood as it moves downstream. Okay. So notice how for each of the points I'm extending it to actually answer the question, how does that help reduce the risk of flooding? Further going down, so they've removed some trees, okay, which you'd normally think is counterproductive. So it's surprising that they've removed trees. But if we remember, our case study actually tells us why they did this. They removed the trees because the trees were what blocked. They were collapsed. They went into the river and they blocked up, didn't they, the water from being able to flow. So by removing trees near to the riverbank, this will prevent them from falling, collapsing, or branches falling into the river and blocking up the river, causing it to back up and to flood, which is basically what happened in Boscastle. Okay, so that's why they've removed trees. All right, if you're going to plant trees to stop flooding, that needs to be up here. It needs to be up in the hills, doesn't it, where the water's coming from. Okay, right next to the river is not going to make that big a difference particularly. Okay. Where have we got then? So we've got the raising the car parks. Lots about car parks here, isn't it? Raising the car parks. Okay, so by raising the car parks, you're kind of creating a channel, a deeper channel, aren't you? It's a bit like a levee, okay, where the water now can flow, and if it does overflow, it's not going to wash the cars away. It's not going to cause any damage. So it actually is there as almost like a sort of a wall, isn't it? Okay, to protect the river from causing any damage. And you've got the same here with moving the car park upstream away from the river. Okay, so they're the sort of key ideas there that we need to be discussing. So remember, don't just say what's on the figure 15, but say why does that reduce the risk of flooding? That's what the question asks. Okay, so by changing the position of the existing channel, this will reduce the risk of flooding by. So you're really explaining your answer nice and clearly. Okay, that's what we're looking for in this one here. Right. Okay. Moving on then. Back to a map question. All right. So this was our map. So part of the course of the River Annan showing on a 1 to 50,000 Ordnance Survey map. Again, okay, we can see the River Annan there. Right, we'll scroll down. First question then was using figure 15, give one piece of evidence this part of the River Annan is in its lower course. For me, there's one really clear answer, and it's that there's a large, wide, flat valley that the river is flowing through. Okay, so that for me is definitely suggesting that this is in the lower course. We also commenting on meanders, which is okay as well. I mean, it's a difficult one because as the river does get to the sea, it will straighten up a little bit usually. And it's sort of more in the middle course that you tend to get the most meandering. But yeah, I guess with this question, the way they've written it, it's not the upper course, is it? That's what they're really asking you. Why is it not the upper course? So because there were meanders was accepted as well. All right. So wide river valley or wide area of flat land, and there are meanders flowing through as well would be the things to be looking for. That's the evidence you've got on the map. Okay. Moving on to the next question then. So which grid square contains the tributary of the River Annan with the steepest gradient? Now I know this was a tricky question, and we'll just have a little look at it and just try and work it out. So 0877 is the correct answer. Okay, so let's just go to that, 0877. So if we look here, the tributary, that's the tributary there, okay? And if we look here how it's flowing, there's lots and lots of contour lines. Okay, so we see loads of contour lines. So that river is coming down from quite high, very steep, flowing down into the River Annan. Okay, so the other squares, I think this was one of the squares. You can see there are some contours here, but just 3 or 4 of them. So it's going to be flowing much slower. Okay, it's not going to be as steep. I can't remember where the other line was, but it's this one here because of there being so many contour lines steeply close together, and the tributary flows down them. Okay, that's where the tributary is actually going down here. It's a slope, it's going downhill, but it's not as steep. There are less contour lines, and the contour lines are further apart. Okay, so that's the answer to that one there, and the reason for it. So it was this square here, and that river or tributary there that flows down there is quite steep with close together contour lines. All right, tricky question that one. It's hard to sort of spot, but yeah, that's the answer. Next one then was suggest the landform that may form in the future at 108,794. Most of you got this one correct, 108,794. So 108,794. So here, isn't it? So it's this area here, and we can see the neck of the meander, the two necks there, the two parts, they're joining together, and eventually perhaps we'll end up with an oxbow lake here, okay, that's been left behind. Perhaps that's an old oxbow lake there, I wonder. I don't know. Okay, but yeah, because the two bends of the meander are coming close together, it may well be in the future we'll get an oxbow lake forming there. Okay, I think most of us got that. All right, back down. Okay, so then on to our hydrograph. Okay, so our hydrograph showing our rainfall event. Okay, where we've got our rain flowing through the morning of day one. Okay, for a fair few hours, peaking at 6 a.m. in the morning, isn't it? That's when the highest amount was. And then we've got going over the next few days what happens to the river. Okay, so this is the river itself starts filling up, reaches its peak here, okay, and then obviously starts to fall down. So that's when the most amount of water is in the river, and it's at what, 22 cumex, 22 cubic meters per second. All right, and that occurs at what time does it occur? It occurs at 6 p.m. So it's 6 in the afternoon on day 2. All right. So the question asks us, I think, yeah, what was the lag time between the peak rainfall and peak discharge? So let's have a little look. So we start there at 6 a.m. That's when the peak rainfall occurs because it's the highest point. And we've got to go across and get to here where the peak discharge is, get our lag time. So each of these boxes is 6 hours, isn't it? Okay, so we go from 6 a.m. to 12 p.m. So that's 6 hours. And then we've got a whole day here. Okay, so that's 24, isn't it? It's 24 add 6, 30. And then we've got another 6 hours to get to the afternoon. So 36 hours. So 6 boxes, 6 along there equals 36 hours. All right. So from when this water that fell on the ground here has taken 36 hours to get to this part of the river as it's discharged. That's what it's showing us, isn't it? Okay. So 36 hours was the correct answer for that one. All right, for the lag time. Next then is a little suggest question. Suggest one way that cutting down trees near the river in figure 16 may affect the hydrograph. You have to refer to the hydrograph in this question. A few of you gave a correct answer, as in you knew what would happen, but you didn't say what would change on the hydrograph. Okay, so if we cut trees down, let's just scroll back up to the hydrograph itself. If we cut trees down, the lag time is going to be decreased. Okay, so if we cut trees down, this peak is going to move this way, and the peak is also likely to be higher because the water is going to get there quickly. So it'll get there quicker and go higher. So they'd be the two things: higher peak discharge and longer lag time. And shorter lag time if we cut trees down. Okay, so it's directly what the impact are on the graph. That's what the question's asking us for. Okay, again, you've got to make sure you read exactly what's the question saying. Right, next one then was study figure 17, a photograph showing part of the River Skifere in North Yorkshire. Now, this question is a much easier question than I think a lot of you realised. All right, I think you got confused by it and by the way that it was written. We'll just go through it now, but it says here, explain how a combination of erosional and depositional processes have led to the formation of the landform shown in figure 17. Well, what is this landform? It's a meander. The question basically says, explain a meander to me. That's all it's asking you to do. It's wanting you to say, how does a meander form? All right. So again, it's the kind of question where you could throw in some diagrams. You'd need to mention figure 17 because it asks you to, Okay, but it is just telling you to say, this is a river channel where it's steep on deep on the outside, where the water is flowing faster, therefore eroding here and creating a river cliff. The water flowing on the inside of the bend is much slower, therefore it has less energy and is dropping material off, create the slip-off slope or the river beach. Okay, that is all this question is asking you to do. It just wants you to talk about meanders. It's not really, it's not anything else. So if the answer to this could be rewritten as explain how a meander forms. Okay, that's all you needed to do for this question. And quite a few of you, I think, maybe confused you a bit by having the picture and you weren't quite sure what you were doing. I think if you'd recognise that's all it was asking you to do, then I think you've probably given a better answer. So just be careful when you're reading. Just get, obviously this comes from practice and going through papers, and especially in the build up to your exams, going through as many of your old papers that you've done before, and just remind yourself what kinds of questions they have, because they'll ask similar questions all the time. And so this one is just saying explain a meander, and mention figure 17 as well, will you? As it does here, figure 17 shows a landform called a meander. Perfect. That would be the end of your comments on figure 17, would be absolutely fine. Then all you need to do is explain the formation of a meander, talking about erosion and deposition. Okay, right. So next one. This was a tricky little question, this one, definitely. So study figure 18, a map of the Eden Basin in the northwest of England. Okay, so we can see here that we've got the Lake District here. Now, permeable. Most of us, I think, understood this, but there is a key thing. Permeable means water can go through it. Impermeable means water can't go through it. It does not mean that they can be more easily eroded. Permeable rocks doesn't mean that they're not hard rocks. It doesn't mean that they're easily eroded. Okay, lots of you commented on erosion here. There is no reason for you to talk about erosion. Okay, it is not relevant. Impermeable rocks can sometimes be quite easily eroded, and some permeable rocks are very difficult to erode. It's just to do with whether water could go through and pass through them. That's all. All right. So please do be careful about sort of making assumptions on things, because that's, that was one that lots of you mentioned, is erosion, and saying all permeable rocks are more easily eroded. Well, they're not always, so that isn't necessarily true. Okay, and also we identify we've got some urban areas. 1, 2, there's 3, aren't there? 3 urban areas, and we've got then our drainage basin area that's drained by this river. Okay, so the question then, using figure 18 and your own understanding, explain how physical and human factors may affect flood risk in the Eden Basin. So 3 things again, isn't it? Talk about figure 18, talk about physical factors, talk about human factors, and link all of that stuff to flood risk. You must be talking about flood risk here, otherwise you're not answering the question. Okay, just describing what's on the map isn't answering the question. So in figure 18, I can see there's four urban areas. These 4 urban areas will maybe have a lot of concrete in them, which will increase the runoff of water going into the river very quickly. Okay, they are also located right next to the river. Therefore, they are in the area of floodplain, which is likely to flood regularly. Okay, so the urban areas are all built by the river. They're all in the area that's most likely to flood, aren't they? Okay, so we can comment on that. So we've started then talking about human factors, and we're talking about the figure 18, aren't we? Next thing we could comment on, no problem talking about impermeable rocks here. So the impermeable rocks located to the southwest of the drainage basin will increase runoff, as water will not be able to soak deep into the ground. This will increase runoff, meaning that water will get into the river very quickly, causing it to have a very high discharge after heavy rain, which will be likely to make it flood. Okay, so it's going to make it likely to flood, won't it? You could talk about the fact that there are a number of tributaries that join, which will bring the water very quickly into this river. especially in Carlisle. Look, you've got two big tributaries coming right the way down, haven't you? Joining the river at Carlisle. You're going to have a lot of water suddenly potentially being added to the river at Carlisle. All right, so that would be another reason why you've got a sort of a physical factor that could increase the chance of there being a flood in Carlisle. A few people correctly talked about the fact there's lots of upland area very close to this river. Therefore, it's going to be very steep slopes, so water's going to move very quickly into the river as well, therefore making it more likely to flood. They'd be the sorts of things you'd want to really discuss here. Okay. And again, a bit of detail, mentioning the words figure 18 in your answer. You can get up to the top end. Again, the quality of your writing is key here. Have you linked things together? Okay, and that then is the end of the feedback on the rivers section. If you have any very specific questions about what you've written and an answer that you've got and you can't understand why I've given you that mark, or you want to, probably the best thing for you to do is to actually screenshot it. So if it was this one, for example, if you can take a screenshot of that and then you can kind of send it to me with your question, it'll make it that bit easier for me to hunt it down, and I can sort of talk about it straight away as to why I've given you the mark that I've given for that. Okay, so that would be my suggestion. But please do, this is a general feedback to everybody. You'll each have individual things where you might not have fit the pattern here, or you're not quite sure why you've got a mark. Please make sure you do ask and find out, because it's the key to being successful, is understanding your mistakes, understanding where you've gone wrong or not quite understood something, and then trying not to make that same mistake again. So as I've said already, they do ask very similar questions in the exams time and time again. Okay, they don't come up with loads of totally different questions. They just come up with a different map or a different, a different place to look at, but they ask very similar questions about it. Okay, right, that's the end of the feedback then. Okay, bye.